Okay, so let's kind of start talking through this stuff here. Like I said, I don't know that it's going to be life or death that we understand this super well. When I set it up for like the quiz and the test, I made sure it was questions that like are things we specifically talked about, and hopefully we can talk through it and it shouldn't be too bad. But there's kind of a lot that actually happens with this end behavior stuff. So end behavior in general, if you look that up, it says in a sequence T, the behavior of values T sub n as n, and then it has that arrow, and you guys know the sideways 8 is infinity, right? So what that means is as our values of n approach infinity, what happens, okay? So what we're going to think there is as we kind of go along the x-axis, does our graph approach something or does it not approach something is basically what we're trying to figure out here. And then our notation that we use for this is this stuff here. So for limits, they just put it as limit, and then underneath it, it tells you what value you're trying to approach. So like here, it's the limit of c sub n as n approaches infinity. So that basically just tells you what number you're trying to go to, okay? For now, from what I can tell, we're only going to infinity. There are situations where you'll go to negative infinity. So negative infinity, instead of going like all the way as far as you can to the right, it would be all the way as far as you can to the left. Or, infinity can also go up and down. So like positive infinity would be up forever, negative infinity is down forever. If you do get into calc or want to go that route, sometimes they'll have it approach a number as well. So it might be like n and then an arrow and then a number. Sometimes they do that too. As far as I can tell, though, all of our stuff just approaches positive infinity, so we don't need to worry too much about that other stuff. So some of the questions that they're going to ask you, they're going to ask you if they give you some sort of sequence, if it's convergent or divergent. I actually want to talk about the convergent one first here. So convergent sequence, and then the definition of that, it says a sequence which has a finite limit value. Finite means it just goes to like a specific value, like it's actually going to have a number that it would represent. The opposite of that would be like infinite or like non-finite or whatever, where it's not going to an actual specific thing. So the finite ones, it's going to be a specific thing that it goes to. So it says which has a finite value L, that's just whatever your limit is. If this value exists, then the sequence is said to be convergent. So if it goes to a said value or whatever, like a number, then it fits in this category. If it doesn't, it fits in the divergent category, which we'll look at. So what they're kind of getting at here is if I had this graph of a sequence and it was something like this where I just got all these points kind of graphed and it's kind of going downhill like this, and I get really, really, really close to this line, but never actually cross it. You remember we talked about like asymptotes? So if something has a horizontal asymptote, which is what it kind of says there, so convergent stuff has horizontal asymptotes. So if it does that, if it gets closer and closer and closer and closer and closer to something, but it doesn't actually hit that, that's the limit that it's approaching, okay? So in this case, so this sequence that they would be using to come up with these individual points. They call it the harmonic sequence. We're going to use it quite a bit, but it's basically just where we've got like c sub n or whatever, and then it's 1 over n. Why this is happening is, can we ever have a 0 on the bottom for that n? Like, can we take 1 and divide it by 0? No. So if our bottom is ever like that, where it's just like that variable, we know that that bottom can never equal 0. So we know what's going to happen to that graph is it's just going to keep getting closer and closer and closer and closer to 0, but it's never going to cross it, okay? So what you would say in that case is you would say that your limit of that is 0 because it gets closer and closer and closer to it, but it doesn't hit it. So when they say like the thing where we were talking about the infinity before, so like as n goes to infinity, what they're saying with that is like we're going here and we're working as far as we possibly can to the right, okay? So infinity would be going this way. Again, we're not going to do negative infinity, but if it said something about negative infinity, it'd be asking us that way, okay? So you can have different results sometimes with different graphs, but I think we're going to keep it pretty basic for what we're working on. So a situation like this where it's convergent, it does converge to a number or it approaches a number, okay? And there's an asymptote. Now the opposite of that then would be a situation that's divergent. So for divergent, it says a sequence with no finite limit. So basically it's doing something where it's not approaching a specific value. So like I said, that one before had that asymptote, so it's approaching that specific value. In a case like this is just kind of like a linear one where it's just like negative 2n. what's happening here is our graph just keeps going down and down and down and down and down, but is it ever approaching like an actual value that it's going to like level off at, or is it just going to keep going down and to the right forever? Probably just going to keep going down and to the right forever. So this is where I have a disagreement with the book. So the book just says for this that the limit does not exist. I don't necessarily agree with that, because technically the limit here is negative infinity, because it's going to keep going down and down and down forever. So me personally, I would say the limit here is negative infinity, but the book is saying that it does not exist. I don't care how you answer that. If you answer it as like DNE for does not exist, or that it's like approaching positive or negative infinity, I don't care which way you go, because like I said, I don't agree with what the book is saying. There's got to be a reason that they're not doing the positive negative infinity stuff, but I couldn't really figure it out, and after 4 hours I just gave up. But like I said, I don't care if you put it as limit does not exist or positive or negative infinity. Like I said, in my opinion, as we go across here, it's just going to keep going down. So I would say it approaches negative infinity, or it's going to negative infinity, but I think because it doesn't go to a specific number, that's why they want that. But we'll talk through some examples to kind of show that. The one from the Mean Girls one, if you're curious about that for the limit does not exist, is this graph. So that one, the thing that they're graphing is the log of 1 minus x minus sine x over cosine squared x, and then that graph gets kicked out, and then she just looks at that and doesn't even have the graph and says, yep, the limit does not exist. I don't know how she figures that out, but yeah, so that's the one for Mean Girls, and it doesn't exist in this case because as we approach infinity or whatever, like, it's going like down, but then it's going back up, and it's changing back and forth, so because it's not consistent and it's kind of like oscillating there or whatever, it wouldn't exist in that case. But like I said, don't worry about that. We're gonna keep it basic. Like, there's a lot more to this, but we're gonna try to keep it low key and figure out just exactly what we need to. Okay, so let's go to the next stuff here and write some more stuff down. This graph here is the same graph as what you just had on the previous page, so don't feel like you have to graph it again. You could just write, limit of harmonic sequence or whatever, property, and then you could just draw an arrow back to that other graph because it is that same one we just drew for the convergent stuff. And then this stuff here, the properties of limits and constraints, that stuff is actually in your example packet. It's all written out already, so you don't have to write that in your notes. You could just put that, properties of blah, 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 and then you could just say that it's in your example packet, so if you need to refer back to it, you could just write that. That's what I would do instead of having to write it all the way out again. And then once you get those things kind of jotted down there, we'll look at that picture on page 517 and kind of talk through what that means. So I'll let you guys jot that stuff down if you want to, but like I said, that stuff's in the example packet, so I'd probably just write properties of whatever in example packet or refer to example packet or whatever. So I'll let you guys jot that down, and then we'll talk through some more stuff. And we get out of here at 16, so you'll probably just get it written down, and then we'll probably have to keep talking about this stuff on Monday. And hopefully by then I have all the stuff done for the next couple sections, so I actually know what's going on. Kind of flying by the seat of my pants right now. Instead of a book page, we're going to do a worksheet assignment this time instead, because I want to pick specifically what kind of problems do you want, like, I'm going to have you do versus doing some of the books not so great problems. Do you want the worksheet now, or you just want to wait till Monday? Take it now. I'll give it to you. Like I said, you may or may not have enough information to actually try it or not. The one is just a limit sheet that I found on the internet, and then the other one is actually from the 2 versions ago of this textbook that was published in 1992 before I was born. So it's from the same function statistics and trigonometry by the same people, but it's from 1992. But turns out math doesn't change. Despite what these people say, like, oh, new math. I hate when people say that. Math does not change for the last 1,000